Fiber cement cladding is a century-old product that was actually reinvented in the 1980s. Asbestos was removed due to health concerns and replaced with wood pulp. The pulp provides the fiber that prevents cracking. Production begins with silica sand. A loader shovels it into an underground conveyor. The sand particles, which are about the size of beach sand, are about to be ground down to a fine powder. The conveyor takes the sand up to a revolving cylindrical grinder called a ball mill, so named because inside, steel balls tumble around to smash the sand particles into much smaller bits. They pipe in water to keep the dust down and eliminate the need for an exhaust system. This also liquefies the sand, making it easier to pipe it through the plant during the various stages of processing. But the sandy liquid needs to be thickened substantially, so it's into a tank to drain off much of the water. What's left is about 80% sand. The next ingredient is wood pulp, which gives the cement siding bending strength. Without it, the fiber cement siding would be brittle and crack easily. They add water and stir to soften and liquefy the pulp, so it can be easily pumped around the factory for processing. At the end of the mixing, the pulp looks like thick oatmeal. Next, they lower cylindrical sieves into position. But first, they blend together the liquefied sand, cement, and pulp, along with some additives, creating a fiber cement slurry. They pipe the cement slurry into a trough beneath the sieves. As the sieves rotate through the slurry, residual water drains through the mesh walls, leaving a fiber cement film on the surface. The film transfers to a felt belt moving overhead. Through the felt, a vacuum mechanism sucks more moisture from the film until it forms a solid fiber cement sheet. Rollers squeeze numerous sheets together. They're still moist enough to stick together, and they fuse into one thick board. Another roller then presses a wood-like pattern onto the surface of the cement board. A spray of high-pressure water then slices the cement sheet into planks. A robotic suctioning head gently picks up the fiber cement planks and transfers them to a pallet. The planks are fragile at this point and need to be handled with care. Loaded onto the pallet, the cement planks are now ready for some toughening up. They bake the fiber cement siding inside steel tubes. They're autoclaves, high-pressure ovens. Inside, pressurized steam enhances the chemical reaction between the ingredients to cure the cement clapboard. Then they load the pallets of cement siding onto a rail car, and it's on to the next station. Here, machinery does something they call stack breaking. During curing, the siding planks can get stuck together, so these hydraulic cylinders lift and jostle them to separate them into individual boards. They put a siding sample to the test. With both sides of the board stabilized, a rod bends it at the center to determine the stress point. If it can take a lot of pressure, the whole production line moves forward. Spaced apart now, the fiber cement planks ride by sprayers that paint the sides and the ends a nice shade of red. The siding then enters a curtain of paint of the exact same color. The paint adheres to the front of the boards. These mirrors expose any missed spots. If there are any, they'll do touch-ups. The transformation from a pile of sand and other ingredients to something that looks a lot like wood siding has taken just 3 days. And once installed, these wood-look cement planks could fool the neighbors. After all, it's all about putting up a good facade.